Hello, everyone. I'm Dr. Chad Poole, Water Resiliency, the Extension Specialist with the Department of Biological and Agricultural Engineering at North Carolina State University. Today, I want to talk with you about identifying flood-prone areas with RTK elevation mapping. The image you see on the screen is near and dear to my heart. My family has tended this land since the mid-1990s down in Beaufort County, North Carolina. And since that point in time, it's been affected by multiple tropical events, starting with Hurricane Bertha, that has flooded the land and brought in salt water for the nearby Pamlico Sound. You can see the results in this image of saltwater intrusion that's come about through all these tropical events since the mid-1990s. The white areas represent areas of the farm that are high in salinity, and crops are unable to be grown at that particular site. Prior to the mid-1990s, this was #1 tobacco land. Great land for growing the cash crop and generating high levels of revenue. Unfortunately, due to saltwater intrusion, it's no longer suitable for growing tobacco and many other crops that we're used to in eastern North Carolina. Unfortunately, due to tropical events, we're seeing more and more saltwater intrusion. Hopefully, through the presentation today, I can demonstrate technology that will help us to assess areas that may have been affected by saltwater intrusion or will be affected by saltwater intrusion in the future, so we can plan accordingly to deal with this. This unit that you see on the screen here is part of the Water Resiliency Extension Program at NC State. We can utilize this unit to do RTK topographic mapping of farms and other areas that may be subject to saltwater intrusion. In order for the system to work, you must have an RTK base station, like on the bottom of the screen here, that's set up in the field, a receiving antenna from the global positioning satellites that are orbiting the Earth, and a computer that can collect data from the receiving antenna and the base station and make corrections to generate topographic maps of a particular area that you're surveying. Once that data is generated and saved to the computer, it can be downloaded to other software. And with that, we can create contour maps, we can create watershed drainage maps, and we can also simulate flooding events that could be caused during tidal surges from tropical situations. This image here is some elevation data that we collected at the Pasquotank site. This farm has an area that's been affected by salt water. We have high salinity levels at the site itself. So this is what we were able to generate using the equipment you saw on the previous screen for elevation data. We basically went through this and rode across the parcel in 25, 30-foot swaths and collected elevation data every 10 to 20 foot. And we were able to generate this map. The blue colors represent the lower areas of the field, and the darker red colors represent the higher areas of the field. And you can see we got a pretty nice contour map that shows that water basically flows downhill to this tributary that comes off of the stream that you see coming up from the local river area. We're able to do a lot of stuff with the software to really show what's going on from the topography standpoint. In eastern North Carolina, we typically don't think about a lot of topographic relief. We're fairly flat. But with this, we're able to exaggerate changes in elevation to really see what's going on in the field. And this is a vertical exaggeration of that collected field data. And you can tell that there is a significant valley running across this field. It actually expands up this way. And then there's some lower areas on the, I guess this would be the southern end of this particular parcel that can hold water and may be affected by flooding conditions and high intensity rainfall events, or either when the river levels rise. One other thing we can do when we have this data is actually do a flooding analysis. And this is the result of assuming that we have a 1 foot elevation in sea level rise, or a flooding scenario where we have a tropical event and it blows water up the sounds and rivers and puts at least 1 foot of water into the tributary adjoining the farm. When that happens, this part of the field would be inundated with water. So when we had that tropical event that would bring salt water in from the sounds, at 1 foot of rise in the elevation of the sounds and rivers, we would have basically salt water could enter this part of the field. Carrying that analysis a little bit further and looking at a 1.5 foot inundation, so just 1.5 foot of sea level rise during a tropical event, and we would have this area of the farm that would be inundated with salt water. And you can see those low areas become really apparent as you do this type of analysis. Now, this data here was provided by the folks at ECU. This is conductivity measurements, and this is where we could expect to see high levels of salt in the fields. They actually went out and took these measurements on site. And what I want you to really notice is that where these ponding areas would occur, we have fairly high levels of salt compared to everything else at the site. The higher elevation areas that would be shown in red, for the most part, do not have as high conductivity. So that would basically lean to the fact that these flooding areas are more prone to having high levels of salt in the field based on the elevation data. So now I want to switch gears and change to the second site, which is in Camden County. We're calling this the Camden site. It's also adjacent to the sound and river basin up there. And you can tell from the elevation data that was collected at this site, there's quite a bit of change in elevation as you move from the areas closest to the sound, basically uphill, moving away from the sound. We have a huge ridge that separates this area from these lower areas that are affected by tidal surges. And we've got a pretty good map here of that data. You can see the areas in blue will be the lowest elevations at the site. And again, this is reference to sea level. And then up here would be the highest elevations at the site. Looking again at vertical exaggeration, where we can really show those differences, you can see that actually we almost have a floodplain up to a nice ridge. And that ridge is basically going to act as a dike to keep flood waters from getting up in this area of the profile. And you can clearly tell when you go to this site, there's not a lot of issues with crops growing on the upper ridge. Most of those issues are occurring down here on this lower area of this particular field. Doing the same type analysis for flooding at 1 foot of inundation, we only have a few areas in the field that would see water standing that would be coming out of these lateral ditches that are coming up into the site. Part of the field was so wet when we were out doing the survey, we weren't able to survey it, and that's represented by this little area here. Most likely that would probably be underwater with a 1 foot tidal inundation, but we weren't able to gather that information. Moving on to the 1.5 foot, and we begin to get a significant inundation in this floodplain area. And as you begin to move uphill, that kind of goes away. So you can see that during a tropical event that will bring water into the sound to a level of 18 inches above normal tides, it's very likely that salt water would enter the site. And I think that's probably happened in the past, which again is evident by the conductivity data that was provided by ECU. You can see that the higher conductivity values are in this floodplain area, these lower elevation areas, compared to the uphill areas here where we have much lower conductivities. So it seems to be apparent, at least at these two sites, that a lot of the salinity issues that we are observing are due to probably tidal influxes during some sort of tropical event where water is coming in on the sites themselves. I carried this one a little bit further because I wanted to see what would happen if we increase the tidal influence at 1.75 feet. We basically inundate almost that entire floodplain area except this little section before you begin to get on the ridge where that topographic relief really takes over. Carrying that one step further and going to a 2 foot inundation, you're all the way to that ridge where we begin to go uphill very rapidly. So just a 2 foot tidal surge, and we're going to carry that whole producer's field or landowner's field basically underwater up into the ridge. And salt water could affect all those areas.